Hello everyone. This video is for external flow problem of flow passed through the elliptic body. In fluid mechanics, there is two types of problem. One is internal flow problem where we have walls or boundaries all around the flow, and second one is external flow, which have free stream of fluid outside the boundary layer. In this video, we will be studying the external flow problem of a flow passed through the elliptic body with minor axis along streamwise direction using open form. Here we have two governing equations. First one is continuity equation and second one is momentum equation. Talking about the boundary conditions, we have pressure boundary conditions and velocity boundary conditions. At the walls we have Newman boundary conditions for the pressure, and at inlet also we have Newman boundary condition, that is the derivative of the pressure is zero at walls and inlet, and outlet we have a fixed value of our pressure, that is Dirichlet boundary conditions. And now talking about velocity boundary conditions, they have at the walls no slip condition. It means that all the components of velocity is zero at walls, and it inlets we have fixed value of the uniform velocity in the x direction, that is the Dirichlet condition. And at outlet we have Newman condition for the velocity. Now talking about workflow chart. So in this problem, we are using OpenFOAM to solve the problem, because OpenFOAM is an open source code which is used to simulate these problems. So there is a standard workflow. Like first we will make the geometry, then we will set this settings of the solvers, then we will define our boundary conditions, then we will run the solver and do, and then after that we will do some post processing, that is the we will do uh, we will see the graphs of the velocity and the pressure. So now talking about our description of our geometry. So we have our fluid domain, and inside that we have our elliptic obstacle whose minor axis is along the streamwise directions. So to make the ellipse, we have taken the center point of the ellipse to 5, and in the right side of the center we have taken 2.5 and 5 to make to make the minor axis of the ellipse of the length 1 meter and 1 unit, and to make the major axis of 2 unit, we have taken the points 2, 4 and 2, 6. So all the boundary conditions are mentioned here, no slip boundary conditions, and this one is the inlet and this is the outlet. So now we will form our first we will make our geometry in the open form, and open form is open form works well in Linux, so we will use a virtual machine. So this is the virtual machine, and we had already opened the Ubuntu. So this is the graphic interface of the user interface of the Ubuntu. So now we will first make the folder of our geometry in here. So to make that, first we will open the terminal by Control Alt T, and we will make our folder, that is by this command. Okay, dir. Let's say the name of our folder is ellipse. Okay, and let's open this. As this is the empty because we hadn't put anything in this folder, so make geometry folder in this. So geometry folder has been made. Now look into the geometry folder. So this is empty now. So we will make the geometry gmsh. Uh, ellipse dot geo. So it is open now. So as we are making the fluid domain and the cavity, so first we will make the fluid domain by selecting the points. First add the points. So our fluid domain is 15 unit long and 10 unit wide. So our first point will be 15 0 and second point will be our 0 0. Sorry, 0 0. And now our third point will be 15 10 10 and fourth point will be 0 10. So we had got our 4 points. So now we will make line from them. So select first point, select second point, select first point, select second point, first point, second point. So we had made our lines. So now we will make our cavity. So for cavity, we have to make a point again. So first point will be 2 and second point center. This is the center point. So we will add into here. And to make the ellipse, we will make another points. That is the right to the center, and this is the left to the center. And now we will make top and bottom points. So this is the top point and this is the bottom point. So we will make now ellipse from these points. So to make ellipse, we will choose ellipse arc. So first we have to choose start point. This is our start point, and we have to choose center. This is our center. Now we have to choose a point on major axis. This is the major axis and this is the end point. So same like that again, this point, center point on major axis, and on this point, center on major axis, end point, this point, center on major axis, and end point. So we had made our geometry. Now we have to form the surface from this 1D structure. So to make that, we will choose plane surface. We will choose the outer boundary. So first we have to about this all this. So choose plane surface, choose outer boundary, choose whole boundary, that is our ellipse. Okay, then press E to eliminate and Q to abort. So we had made our plane surface from the sketch. So now we will extrude this to convert into 3D. So to convert into 3D, we will choose translate and we will choose the thickness is equal to 1 unit and mesh layer would be 1. So choose this plane 1. So whole entities will be extruded. So E2 and selection and Q2 about. So now this our geometry has been converted into 3D. So now we had to make some another's, like we had to make physical groups, like we have to give the name to the boundaries. So first we will add from the physical groups, we will add surface. So first will be our inlet. Mm, This is our inlet plane area, E2 and selection. Then our bottom, this is our bottom, E2 and selection. Then we have our top, that this is our top, E2 and selection. This is our outlet. This is outlet, E2 and selection. Now we have to make surface for the ellipse. Select all the surfaces, all the planes of the ellipse. E2 and selection. And now for front back. This is front, this is back. Now E2 and selection and Q2 about. So we had made the boundary conditions for our geometry. Now we can check in edit scripts like we had seen physical surfaces. But another thing we have to do, we have to make for volume also. So this is our volume and choose this sphere to select the volume, E2 and selection and Q2 about. So one more thing we had to do, that we had to first make another, that layers. This is used for the extrude element, and layers curly bracket, and here it is 1 in the extrude, that is thickness 1, so only one layer will be used. So and then we will use another command, recombine, sorry, recombine, and use this in the end. Yeah, now we are holding to go for mesh. So now reload the script and check the script. Okay, all fine. So now we will do the meshing. So for meshing, select first 1D, then 2D, then 3D. So here we can see that it is all in the 3D mesh, but one more, but we want one more thing, that we want mesh is finer around these obstacles. So to make that, go to the edit script as these are the points of the ellipse. So these are the characteristic length of the mesh. So change to it point 1, point 1, point 1, point 1, point 1. So as these are the 5 points, let's change the characteristic length to 0.41. Save this script and then reload the go to 2D, then 1D, then reload the script. First check the script. Okay, it's all good. Save. Then go to the 1D, then 2D, then 3D. So we can see that message cursor around these points. So now we are all done with our geometry and mesh. So now save the mesh and export it. Ellipse, choose ellipse.mesh, and yeah, choose the version second because it works for open form. So we are all done with this, so we can cut this. So now mm, we had all this. Now we have to follow. Now we have to give the boundary conditions to our problem. So for that, so for that, we will take the help of the tutorials that are from the open form tutorials. So to do that, first open the terminal. So yeah, choose cd opt, then do ls, then cd open form 10 ls, then choose tutorials, cd tutorials, then ls show. Then we have to choose incompressible because our problem is incompressible. So cd incompressible. Okay, ls. Then we have to choose icoform because it is used for laminar problem. Uh, what happened? Let's see. Okay, cd icoform, not only icoform. Actually, we had capitalize I, but we had to take simple I and absolute capital. Now it works. Now ls. Now we have to choose the cavity problem because it is the most closest problem to our problem. So choose CVT CD cavity folder ls. So choose CD cavity ls. Now we have to copy paste these zero constant and system folder into our folder. So to do that, we have to give a following command. So before that, we will go back to the our cavity folder. So So that command is cp r cavity, because it is the cavity folder we have to do. So and we will do choose command desktop, yeah, desktop ellipse, and yeah, we are all done. So now this is the cavity folder here that we had copied from the tutorials. So here we will go to the constant, we will cut this and paste it outside here, and now we can delete this folder. So now mm, one thing we have to do again, like we have to copy this and paste here. So now we have to set some boundary conditions. So go to the system, sorry, go to the here, and one more thing we can do that uh, we can open this in terminal. So now we can give command gms to form and the name of our store time message. This is the name now. Yeah, this is the name of our, and yeah, all good. This is converted to the form. So now we can go to the constant and polymesh. So one more thing we can do that we can copy this physical properties and paste it here. So now we can go. So now uh, we can go to first polymesh and choose the here. Here all these boundaries are of the type patch, but we don't need all the type patch. We will need this type of the wall, and we will delete this. Top should be also wall. Delete this. Inlet should be wall. Inlet should be patch, and physical type should remain patch. This also wall. Actually, front back should be empty, and outlet should be patch, and ellipse should be wall. So remove this. So we are all done with this. This is empty wall, patch, wall, and we have to remove this patch wall. So now save this. Now go to the here 0, and now we have to make these boundaries conditions, like moving wall should be 0 gradient and fixed wall should be 0 gradient, but front and back should be empty. But our boundaries, but our boundary field are not of this type. Our boundary field are of type inlet, outlet, top, bottom, front, back, and ellipse. So we have to modify these boundary field according to our boundary field. So for that, I had already made the boundaries. So I will copy from here because I had already made my boundary conditions. So and I will paste it here. So front wax would be of empty type, pressure, and boundary filled top, inlet, bottom, zero gradient, outlet fixed value of zero, uniform zero, and ellipse should be zero gradient. So you will see here. And now for the velocity, and same I had done for the velocity already. So I will copy it from here and I'll paste it to here. So front back should be empty, top no slip, inlet fixed value of 1. Only the U component is equal to 1, bottom no slip, outlet zero gradient, and ellipse no slip. I also save here. So now after doing that, we have to do one more thing. I will copy this folder and okay, I had already did. Okay, so now we have to go to the system and open control dict. We will change this time period from 0.5 second to 30 second to see the more effect with the time. So save here and now go to this terminal. Yeah, with this now check our mesh. Yeah, mesh is okay. So now so this is running good. So it will take some time because we had done the time setting is equal to 30 second. So it is done. Now we will open the paraform. Okay, it should be small p. Okay, so this is the graphical user interface of paraform. So this is our cavity open form geometry apply to this. So yeah, this is our geometry and this is the